In this video, I'd like to talk about the math question of the day for Saturday, August 19th, 2023. And for this problem, we need to determine the equation of the tangent line to this function f of x at an x value of 1/2. And questions like these are typically seen in Calculus 1 classes. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And before we look at this question specifically, let's think about the general strategy for finding the equation of a tangent line to a function at a given point. And if we had some random function, let me quickly draw in a coordinate plane. Let's say we have some function, which we can call g of x. And let's say we want to know the tangent line may be at this x value. We can call this x sub 0. So we have this point right here on our curve. And the line that is tangent to this, we could draw in. It'll just touch the graph at that one point there. This tangent line can be found by looking at the derivative of our function. Since remember that the derivative tells us the slope of a line that's tangent to a given point. So if we had some other point and we found its derivative at that point, that would tell us what the slope of this tangent line is. So the derivative will tell us the slope of the line that's tangent at a given point. And then from there, we can use the coordinate point with the slope to find the equation of the tangent line. So let's start by first finding the derivative of the function. We have f of x is 5 divided by x. And let's start by rewriting this as 5 multiplied by x to the -1 power. So then we can use the power rule for derivatives. We can take the derivative of our function f with respect to x. And using the power rule, we bring down our exponent and we multiply. We have -5 multiplied by x to the -2 since we subtract the exponent by 1. And if we want, we could write this as -5 over x squared. But we need to find the derivative at this particular x value. So let's plug that in. We have f prime of 1/2. And that gives us -5 over 1/2 squared. And we know 1/2 times by 1/2 is just 1/4. So this is -5 over 1/4. And we're dividing by a fraction, which is the same as multiplying by this fraction flipped over. And -5 times by 4 would give us -20. So we have the slope of the line. This is the slope of our tangent line. We can call this m if we want, since remember the equation of a line we can write in slope-intercept form as y is equal to mx plus b, where m is our slope and b is our y-intercept. So we have the slope, but now we need to figure out what the y-intercept will be. And if you want, you could also use point-slope form. Y minus y1 is m multiplied by x minus x1, where in point-slope form, we need to figure out what x1 and y1 are. And to do that, we have our x value, and if we just plug that into our original function, we can figure out the y value. So let's do that. Using point-slope will be a little bit more straightforward than slope-intercept form, but this would be completely valid as well, since we know m, we know x is 1/2, and we can figure out what the y value will be when x is 1/2. We have f of 1/2. We're determining that y value when x is equal to 1/2. We have 5 divided by 1/2, and we're dividing by a fraction, which is the same as multiplying by this flipped. So we have 5 times by 2, which is 10, meaning that at an x value of 1/2, the function goes through a y value of 10. So we have our coordinate point at 1/2, comma 10, and we have our slope. So we can use our point-slope form now. We can call this x1 and this y1. Let me just make a bit of room so that we can finish working here. And we'll just plug in what we know to this point-slope formula. We have y minus y1, which is 10. It's equal to our slope m, which is -20, multiplied by x minus x1, which is 1/2. So let's simplify this. Let's solve for y. We'll add 10 to the other side and distribute the negative 20. So that we get y is minus 20x. And distributing the negative 20, we would get negative 20 multiplied by minus 1/2. The negatives cancel. 20 over 2 is 10. So we're really just adding 10. And then we have this plus 10 on each side, since we're moving the minus 10 to the right-hand side. So in total, we're adding 10 twice, or we're adding 20. And this right here should be the equation of the line that is tangent to this function at this given x value.